Hi guys, welcome to programming. Today we are going to know how to check whether a given number is prime number or not. Prime number. Let us have a look at a definition. A number that divisible only by itself and 1. For an example, 2, 3, 5, 7, 11, 13 are called as prime numbers. We have several methods to check whether a given number is prime number or not. Let's assume n as given number. Okay, we will going to discuss about 4 methods to check whether given number is prime number or not. The first one, checking from 1 to n both included. That means for an example, if 97 is entered number, we have to check 1 to 97. That means the number of digits required is 97, for example of 97. And then 2, checking from 2 to m-1. If any number is divisible by n, dividing n successfully, then it is not a prime number. Otherwise, it's a prime number. So it's normally equals to the first one, but if it has a break condition, so it helps to avoid time complexity. It definitely reduces the time complexity comparing to the one, because although we found a successful divisor, we will continue the division operations in the first method, but we will stop the process in the second method. So here 97 won't be divisible by any number other than 1 and 97. So number of divisors are required are 95, because 1 and 97 are excluded. So 97 minus 2 equals to 95. So number of divisions required are 95. And then checking from 2 to square root of n. Same as the process of in method 2, we have to check from 2, but it is the ending number is square root of n is enough. That means 2 to square root n. If any number in this range is successfully dividing n, then it is not a prime number. Otherwise, it's a prime number. So number of divisions required, the maximum number of divisions required are root n. So I can't type the root symbol here, so I'm just copying. So number of divisions required are root n. So for an example 97, root n are 9 point something we will get, but the floor value of that value is 9. So we need 2 to 9 operation, 2 to 9. That means just 8 divisions are required. So then the checking with the prime numbers from 2 to square root n. Here same as an example 3, and we have reduced it furthermore. That is, we just need to divide with the only prime numbers in between that range. That means for example, to check 97 prime number or not, we just need to check with the prime numbers below floor of 97 or square root of 97, that is 9. So that means the prime numbers below 9, those are just 2, 3, 5, 7 are enough to check 97 is a prime number or not. Very funny, right? So that means the number of division required here is 4. So out of this, which method is best time complexity method? Everyone says that the fourth method is right, but it's not. It won't apply for the each and every condition, because let us have a because we have to find the prime numbers in that range also. That means we have to find the 2, 3, 5, 7 as a prime numbers also. If we already have a list, then it will be the minimum best method for checking prime number. But when we don't know, that means we have to find these prime numbers also. So it will be quite hard for checking these numbers. So when will be the fourth method will be problem more than 3? Let us have a condition like uh, I just need to find whether 10 lakhs, what is it called as, sorry, it is 1 lakh 1. We don't know that 1 lakh 1 is a prime number or not. To, to compare, to check whether it is a prime number or not, we need to find the square root of 1 lakh means 100. Not 100. I think it's more than. Okay. Let's have an example as 10,001. For comparing the 10,001 numbers, by the first method we need 1001 operations in first method. We need uh, 9,999 in second method, and the square root of 100 means so 100 in third method. But uh, how many operations needed by the 4? Everybody will say 25, I think, because number of prime numbers between in the range of 100 or 25, everyone say. But it's not only 25, because we have to find that prime numbers again. That means we have to find these 25 prime numbers also. So it will take again some more operations. So when you have only one number to compare whether it is a prime number or not, then we have to select. We need to choose third method for the best optimal result. But if we give an array like 10,001, 10,003, 10,005, 10,007, if I gave you these many numbers, then you can directly choose the fourth method. Fourth method, because we will find the prime numbers in between square root of 10,007, and then those are enough to find all these numbers. So in this condition, the fourth one will be best option. But when we are just checking a one number, then third method is the best method. Hope you understand why. And we are going to write the programs for these four types in the four types now. Okay, let us take an I'm writing a program here for just comparing one number is a prime number or not. So this program is for method 1. Okay, so the main, we need to scan a number. We are taking an integer, so into t, scanning that number t, and then by the method of the first one, what is the first method? We're checking from 1 to 97, 1 to the given number, and then we have to compare the successful divisors of 2 or not. So this is the easiest method to write, but it is not a method which is using by more people. I will tell the next what is the most using method for calculating the prime number. Okay, so int count equal to 0. This count is for comparing. This count is for number of successful divisors. Okay. Next, so we have to loop right from 1 to up to t, and then if given t is divided by I, that means equal to 0 means successfully divided. Hope you know it, because percentage gives remainder value, successful divisor. So what should we do? We have to increment the count, right? Because I is a successful divisor. After that, we have to check that if count equals to 2. That means when 1 and the t will be successful divisors, then its count will be 2. Other than it won't be it will increase the count value would be more than 2. So if count equals to 2, that means it is a prime number. We can conclude this prime number. Else, that means it is not a prime number. Okay, return 0 for the successful submission. We will then just executing it. Here is a console and we enter 97. It's a prime number. So this is the method 1. As we already said, the number of division operations need are 97 here, and this will be the, let's write the code for second method. So I was string and then using namespace std. This is a comment method 2, just to understand. Okay, the main, we have to scan t value. What I have said, we have to check. That means int I equals to 2, while I less than t. If t percentage I equals to 0, here we can understand that it will run up to the previous number of t, right? And it is already said, as already said, that it is for successful divisor. So if something dividing it successfully more than 1 and t, so that means we can conclude that count it is not a prime number. So return 0. So else it's a prime number. Return 0. Hope you understand this program. And I have a question: is this program is valid for each and every number? If you say yes, then you are wrong, because I will show you the wrong info. Because when we give any other number, sorry, I forgot to increment I plus plus. If you say it is now also it is not a correct program. For all other values like 97, it gives the prime number. For all other values other than 1, it shows the correct value, but for the 1 it shows the wrong value, because the 1 won't enter into this loop and it gives the prime number. So let's check it. Okay, I will show you why what happening when it is for 1. So it's showing prime number. As I have already said that when t equals to 1, that means I just wrote this code to tell you. Without this, that means I will be 2 and t will be the 1. That means while condition will be false. So it will go to this, it won't enter to this while loop, and it should print the as prime number. So that's why we have to include this special condition for 1. So hope you understand this. This is the method which is being used by more people, because the most number of people don't know that third method will work. So as an experienced person, I would suggest you to use the third one for the better time complexity. Because, and the fourth one is the best method also. Although fourth method is the best method for more array of numbers, I would suggest to use the third method for that word also, because the fourth one is too much complex for the beginners. It won't be understandable that much easily comparing to the third. So I would recommend you to use the third method more. So I will write the third method here. So to use the third method, I have to scan a number. So scanning a number, and then as I already said that for int I equals to 2 less than square root of t means, so if you say, and then here your coding skills will be proved. I am using I will tell what I mean square root of t I plus plus. If t percent I equal 0, so prime. So okay, I write the conditional to square root of t. I have to use less than or equals to. If I didn't use this less than, if I use this less than, I would get that. I will show you why that square root are equal to come here. Okay, t square root. Okay, square root is defined in math. C math and C++. Okay. For 97, it's a prime number, but when it comes to the 49, for example, I gave you 49. What do you expect? It's not a prime number, right? Because 7 into 7 divides it successfully, so 7 is a successful divisor of 49, so it is not a prime number, but you will get as a prime number here because you didn't use square root of r equal to here. Okay, so compile and run now. Here when 49 is entered, it's not a prime, so we got the result. Okay, whatever you I said that you will came to know that how much programming skills you have. Here I am using square root here. If you know the basics of the for loop, that means for the for loop, it enters here, it will check the condition, it executes this section, it comes this section, and then this statement, if it's true and if it executes, and it continues this process. But so that means to checking when I have to check the condition, every time it finds the square root. That means it takes another time, so much time for this. So I'm just defining here. So I don't need to find square root value again and again. So see here, I'm just finding once and using it every time. But when you define the square root here, you have to calculate the square root value again and again for each and every iteration. Okay, and here also this program also one special condition to have, that is also an event 1, because when 1 comes here, 1 won't be enter into this loop, so it comes here and it shows as a prime number, but 1 is not a prime number. So if t equals to 1, we have to say that we have to print as not a prime and return 0. Okay, hope you understand this code. This is a very much good method because it is a very easiest method to understand and to use it, and the time complexity is very low, so this saves a very good time, so comparing to other two, and it is a very simple one to understand comparing to the next one. So here we go to the fourth one. So I am defining here my program here, my string method. So this is for method 4. Okay. Okay. Here I'm taking variable t, I'm scanning it. I'm telling again, if you have a great idea about vectors and all these things, then only you can understand, because it includes vectors here, has include vector. When you are using a C language, you can do that vector directly, because C doesn't have that much simplicity. That's why I suggest you to learn C++, because C++ have a STL library, so that we can use a wide range of data structures directly, like stack, cube, everything is already been implemented, so we can directly use. But when we came to C, we have to implement it ourselves. So that's why I suggested you C++ language. Okay, whatever. uh, I'm using a vector here. This can be understood from who already know C language and STL library. So here is a vector. If you don't know this concept, just skip it away and use the third method, because it gives a very much efficient result. This is for one who are already expertise in C++, who are really eligible, who are a very good understanding in vectors and other concepts, so they can use it happily. For I equals to 2, I less than, I have to compute up to the square root of prime numbers below the square root of it. So I am again calculating as, so I have to include cmath here. Cmath s is sqrt of t. Okay, this works as a Eratosthenes prime table, which we learned in I think 5th class R itself. So if you remember that Eratosthenes prime table, this is something easiest method to something easier. So up to s I plus plus. So you have to compare the prime numbers already is been. So here I'm taking a bool flag. I'm taking flag as a false. Okay. For int I equals to, I should take 0. I should take j here because I is already taken. So I j less than prime dot size j plus plus. So prime dot size means the vector size. The vectors I'm already saving the prime numbers in prime vector, so it is up to the prime j. So j into 0, j less than primes of j. If number, which number? If j, sorry, if I divides the j, what is it? If I divides, okay, if I divides primes of j, then put a flag as true, and then break statement. So because we don't need to append it. So if flag is already in false statement, that means nothing is dividing here, then we have to prime that push back that I. So here we have the prime numbers in between the square root of that given number. So we just have to check that with that numbers. So int I equal to 0 I less than prime size. So we have, because we have to check with each and every number in the prime vector, and I plus plus and taking as flag as false again. And if okay, we don't need to do that here because we have a return statement, we can return it directly. So given number is t, percentage prime of I. Here I done a mistake. Yes, here prime of I equals to 0. Then we can call it as, then it is not a prime number, right? And we can return here. Otherwise, card it's a prime number. Okay, let's see, is there any exception for this code also? If you take an 1 here, so no primes will be added. So here this loop will be skipped, and this loop also will be skipped, and it will shows the prime number. So we have to write the special code for 1 also, 1 here too. So if it t equals to 1, then sorry, I recorded but it isn't save. So I'm showing that code I have implemented here. So if t equals to 1, so it's not a prime number and returning it. And this is our code. We have to add this I percentage prime number equal to 0. I think I skipped it in the previous section. And yes, completed. Okay, and I gonna add a special syntax here, that is card prime of the end line. That means we are going to print the all prime numbers in between the range of the square root of the given number. That means we're going to check it right now. Compile and run. So console comes 197 enters. It shows the prime numbers in between the range of the square root of the given number 97. That means 2357, and it is a prime number. So we will check for the assignment number 10,001, as we already discussed in the logic section. It is how many numbers? 10,001 is not a prime number. Is not a prime number. We have a see. We enter 10,001 here, and we break it when it is not satisfying the condition. That means here 73 is stopping here. After 73, it's showing that it is not a prime number. That means it is being divisible by 73. Hope you understand it. So you just came to know that how many numbers you need to check whether 10,001 is a prime number or not. Just 25 numbers, right? So but to calculate these prime numbers also, we just need we have a lot it takes a lot of time. So I suggest you to use the third method more. But when you are going to find a array of numbers, when you are going to the array of numbers are primes or not, then this method is useful. So if you understand this, this is for you. Okay, hope you understand. If there is any doubts, just comment below. If you like it, like and share and subscribe for this channel too. Thank you. Bye bye. I will meet you with another code again. Bye bye.